Okay. Bismillah ar-Rahman ar-Rahim. Actually, I forget two problems from section 6.1. So let me do these two problems where we have non-real eigenvalues. It will be the first one. I have a minus lambda I. I'll do it quickly. That will be minus lambda 1 minus 1 minus lambda. That gives me lambda squared plus 1 equals 0. So lambda equal plus or minus I. That will be problem 27. So now for lambda equal I, we'll do for lambda equal I. We'll let V1 to be K1, K2. What will happen? I have minus I, 1 minus 1 minus I times K1, K2 equals 0, 0. So I have minus I K1 plus K2 equals 0. Minus K1 minus I K2 equals 0. Yeah, I noticed just these two equations are the same. You multiply by I, the second one, you will get minus I, and this minus I times I, which is minus I squared, which is minus times minus 1, which is 1. So I have here K1 yeah. So from here, I can get K2 will be I K1. That will be better. So my free variable will be K1. I let K1 equal 1. Then K2 will be I. So it will be my V1. That will be 1 and I. Now for the other lambda, minus I, no need to do the calculation. V2 will be V1 bar. And that will be 1 minus I. Okay. That's it. Now we'll go second one. I do the same thing. A minus lambda I. That will be minus lambda minus 8, 32 minus lambda. That give me what? Strange number. That will be lambda square plus 8 times 32 equal to 0. So lambda square will be minus 8 times 2 times 16, which is minus 16 squared. Yeah, 16 times 16. So lambda will be plus or minus 16i. So for lambda equals 16i, I let V1, K1, K2. This will do the calculation. I have the system minus 16i and minus 8, 32 minus 16i, K1, K2 equals 0, 0. These two equations should be the same. Minus 16i, K1 minus 8, K2. And this is 32, K1 minus 16i, K2. If multiply the you get what? This is minus 32i squared, which is 32. So everything is okay. So you have only one equation. So we'll do the first one. So I have what? Minus 8k2 will be 16i k1. So k2 will be minus 2i k1. Minus 2i k1. Now, my free variable will be k1. So let k1 equal 1. K2 will be minus 2i. You can do it different way. So my V1 will be 1 and minus 2i. Yeah. for lambda equal minus 16i, no need to do anything. V2 will be V1 bar. That will be 1 and 2i. Okay. That's it. Yeah. This is the remaining two questions from 6.1. Now let me do things. Let me continue one 6.2. Yeah, I don't think, yeah. Let me do now 6.2. Okay. Yeah, it's recording everything. Okay. So now let me do this is 6.2, which is about diagonalization of matrices. What's the idea? The idea as in this matrix means what? Just it has A in the diagonal, the rest are zero. And so I can write A as a diagonal matrix as P times D times PM. It's the same P. And the matrix P says that capital B is P inverse AP, which is similar to this one. So we say A and B are similar matrices. Here we say A and B similar matrices. The same thing here. It means similar matrices. Say an n by n matrix A, diagonalizable, if it is similar to plus or minus different P. Okay. Now, so our task is to check. We're giving a matrix here. So we say the matrix A is diagonalizable if it is similar to a diagonal matrix. And they found out if it has n linear independent eigenvectors, then it's diagonalizable. So what's the idea? I will try to find n or k in K linear independent eigenvectors. Yeah. So I'll try to find eigenvectors. And by the way, if you have K eigenvectors associated with distinct eigenvalues, especially with distinct eigenvalues, then all of these eigenvectors are linearly independent. So we say if the n by n matrix has n distinct eigenvalues, then it has K linear independent eigenvectors, then it means it's diagonalizable by this theorem. So what's the idea? I will try to find the eigenvalues, and then we'll find the eigenvectors. If the number of eigenvectors, if the sum of all of these, if the total number of eigenvectors, if I count it for, I have this Si, the basis for diagonal space, lambda I. So I find the union of all of these eigenspaces. If I have n eigenvectors, then the matrix is diagonalizable. Let me do the algorithm. First, I'll find the eigenvalues, the eigenvectors. If the total number of eigenvectors is n, I'm talking about n by n matrix. If the total number of eigenvectors is n, then the matrix is diagonalizable. Otherwise, it's not. If that is what happened, right away, P, just I list the eigenvectors. These are the eigenvectors. And D will be the diagonal matrix where the diagonal has what? The eigenvalues. Be careful. This V1, I should have lambda 1 with it. V2, lambda 2, and so on. It's important to have the eigenvalues in the diagonal in the same order as the eigenvectors in P. Repeat it, just repeat the eigenvalue, but it should be related to its eigenvector. So let me do it by examples. Determine whether or not the given matrix A, and by the way, this is what we have in this section. Just try to find P and D. Check the matrix is diagonalizable or not. When it's diagonalizable, if the total number of eigenvectors is similar to the dimension of the matrix. Okay. N by n to n. Determine whether or not the given matrix A is diagonalizable. If it is, find the diagonalizable matrix P and the diagonal matrix D, such that P inverse AB equal D. Okay. So I have this matrix. What I will do, I'll try to find the eigenvalues. So I solve A minus lambda I, like what we did before. So I have 5 minus lambda minus 6, 2, minus 2 minus lambda. Do the calculation, lambda square. This is what? Minus 3 lambda minus 10 plus 12. Yeah, that will be lambda square minus 3 lambda plus 2. So I have lambda minus 2, lambda minus 1 equals 0. So I have lambda equal 1 and lambda equal 2. These are the eigenvalues. They are distinct. Right away. If they are distinct, what they say here, if the n has n distinct eigenvalues, for sure it will be what? Diagonalizable. Right away, the matrix is diagonalizable. A is diagonalizable. Now, how to find P and D? Okay. What I will do, I'll find the eigenvectors. So we say for lambda equal 1, like what we did before. I have let V1, K1, K2, solve the system. 4 minus 6, 2, minus 3, K1, K2 equals 0, 0. Okay, so I have what? 4K1 minus 6 K2 equals 0, and 2K1 minus 3K2 equals 0. For sure, these two equations are the same, huh? Yeah, multiply by 2 the second one, you get the first one. So I have K1 will be 3 over 2K2. So I let K2 to be 2. I'm getting K1 equals 3. So it is my V1, 3 and 2. Okay. Now for lambda equal 2, lambda equals what? 2, yes. What I'm getting? Let V2 now, K1, K2. Solve the system. I have 3 minus 6, 2 minus 4. K1, K2 equals 0, 0. I'm getting what? 3 K1 minus 6 K2 equals 0. And 2K1 minus 4K2 equals 0. The two equations are the same. Multiply the first by 2 and the second by 3. You will get the same thing. So I have K1 will be equal to K2. Will be equal, yeah. So K1, K2. So my K2 is a free variable. Let's K2 equal 1. K1 will be 2. So my V2 be 2 and 1. Right away. What is P and what is D? If I fix D, this is lambda 1. Let me call this lambda 1. And this is lambda 2. So lambda 1 is 1, 2. This is lambda 1. This is lambda 2. Right away, what will be V? It will be V1. What is V1? 3, 2. And V2, 2, 1. That is V1, V2. Put the same thing. Lambda 1 with V1, lambda 2 with V2. That's it. Yeah, it's the other way. Here, the solution is the other way. It's okay. But I need the 2 with the first one, which is 2, 1. The same thing. 2 is with the 2, with the second one. Another problem, determine whether the given is diagonal or not. Let me do the same thing. A minus lambda I. That give me what? 2 minus lambda 3, 0, 2 minus lambda. So I have what? 2 minus lambda square equals 0. So what will be lambda? Well, lambda will be 2 and 2. So now we'll check for lambda equal to what I have. I have, let B1 will be K1, K2. That will be 0, 3, 0, 0 times K1, K2 equals 0, 0. So I have what? 3K2 equals 0 and 0 equals 0. So I have K2 equals 0. So I have only one free variable, which is K1 only. So let K1 equal 1. So I have only one vector, which is 1, 0. Only one eigenvector. Only one eigenvector. But I have two eigenvalues. So A is not diagonalizable. Okay, that's what we did. So if the total number of eigenvectors is n, where A is 2 by 2 in this case, total number is 1, which is less than 2. So we say A is not diagonalizable. Okay. Let me do more problems. Yeah. Now it's 3 by 3. We'll just we'll do examples, nothing else. Yeah, sometimes the calculation becomes a little bit complicated. A minus lambda I, that will be what? 3 minus lambda 0, 0 minus 4 6 minus lambda 2 16 minus 15 minus 5 minus lambda. Some of them we did before, okay, in section 3.1, because we'll find eigenvalues and eigenvectors. Okay. Then I have what? 3 minus lambda times, I'll do the expansion of the first row. That give me what? 3 minus lambda times what? Lambda square plus 5 lambda minus 6 lambda minus lambda. Correct. Yeah. Minus 30 plus 30. That's it. So I have lambda times lambda minus 1 times 3 minus lambda equals 0. So what are the lambdas? 0, 1, 3. Distinct, real and distinct. Right away, A is diagonalizable. What I need to do, I need to find the eigenvectors. I need to find V1, V2, V3. So let me start. Let me do the same thing. He started with lambda 1 equal 3, lambda 2 equal 1, just to have the same answer. So for lambda 1 equal 3, what I will have? I let V1. Nothing is there, just calculation. Huh? So I have the system that will be 0, 0, 0, minus 4, 3, 2, 16, minus 15, minus 8, times K1, K2, K3, equals 0, 0, 0. Yeah, I can do the system using the, what? Using Gaussian elimination. Yeah. I will interchange, I will make the first row the second one. And the second row is the third one. I can interchange the rows, no problem. And this is 0, 0, 0. So multiply by 4 and add, you will get what? This one will be the same. By 4 and add, that will be 0. This will be 0, 0, 0. Multiply by 4 and add, that will be minus 3. Multiply by 4 and add, that will be 0. So I have what? You have minus 4k1 plus 3k2 plus 2k3 equals 0. And you have minus 3k2 equals 0. So from here, I have k2 equals 0. So I have minus 4k1 plus 2k3 equals 0. So k3 will be equal to k1. So my free variable is k1. So I let k1 equal 1. So k3 equal 2. So my v1 will be what? 1, 0, 2, which is this one. Good. Now for lambda equals what? What was the other lambda? Lambda equal 1. I let v2, k1, k2, k3. That give me the system is what? The system becomes what? I have minus 1, so I have 2, 0, 0, minus 4, 5, 2, 16, minus 15, minus 6. So I'm getting what? I'm getting 2k1 equals 0. And minus 4k1 plus 5k2 2k3 equals 0 and 16k1 minus 15 K2 minus 6 K3 equals 0. So I'm getting K1 equals 0. Now, if K1 equals 0, these two equations are the same. Multiply by minus 3, we'll get the second one. This is 15, sorry. Yeah, so it means I have what? K2 is 2 over 5 minus 2 over 5 K3. So I let K3 to be minus 5, K2 equal 2. So my V2 will be what? 0, 2 minus 5, which is this one. Now the last one, well, lambda equals what? What was the last one? This is lambda 1, this is lambda 2. Well, lambda 3, which is 0. I let V3 so I have the system. You can squeeze it on that. I have 3. This is minus 0, so I have the same equation. So it will be 3, 0, 0, minus 4, 6, 2, 16, minus 15, minus 5, times K1, K2, K3. So that implies what? 3K1 equals 0, minus 4K1. 0. K1 equals 0 here. K2, the two equations are the same. So very clear. I can say K3 will be minus 3K1, K2. K1 is 0 already. So I let K2 1. That implies K3 equal minus 3. So it is my V3. It will be 0, 1, minus 3, which is this one. So what is my D? Let me do it here. D will be lambda 1, lambda 2, lambda 3. And I have lambda 1 is 3, 0, 0, 0, 1, 0, 0, 0, 0. That will be D. What is P? It will be V1, V2, V3. What is V1? 102 and 02 V2 02 minus 5 and the last one 01 minus 3, which is this one. Nothing's difficult, but it has a little bit of calculation. No, let me work out this one, the same thing. Yeah, by the way, yeah, we'll find a minus lambda I. I have what? 4 minus lambda minus 2, 1, 2 minus lambda 1, 2 minus 2, 3 minus lambda. That will be difficult to do. I can multiply the second row by minus 1 and add it to the third row. That maybe will make my calculation a little bit easier. That will be 2 minus lambda 1. Multiply minus 2 by minus 1 and add, that will be 0. By minus 1 and add, that will be lambda minus 2. By minus 1 and add, that will be 2 minus lambda. So the expansion of first column. So I have 4 minus lambda times what? Minus lambda 1, lambda minus 2, 2 minus lambda, minus 2 times what? Cancel this with this. I have minus 2, 1, lambda minus 2, 2 minus lambda. Is it? I cancel the second row and the first column. Yeah, minus 2, 1, lambda minus 2, 2 minus lambda. So it's a matter of calculation. I have 4 minus lambda square minus 2 lambda plus lambda minus 2 minus lambda plus 2 minus lambda plus 2. Because it's minus the rest, okay? I have minus 2 times what here? 2 lambda minus 4 minus lambda plus 2. So that can be what? 4 minus lambda. Here I have what? Lambda square minus 3 lambda plus 2, which is lambda minus 2 times lambda minus 1. Here I have what? Lambda 2 lambda minus 2. So I can take lambda minus 2 common factor. That help. Do the multiplication here. I have minus lambda square. Okay. I have minus lambda square and multiply this by this. Huh? Plus lambda plus 4 lambda plus 5 lambda minus 4 and then minus 2 from here. Take minus common factor. You have lambda square minus 5 lambda plus 6. That give me 1 lambda minus 2 lambda minus 2 lambda minus 3. So actually it's minus lambda minus 2 squared times lambda minus 3 equals 0. So the eigenvalues lambda equal 2 with the multiplicity 2 and lambda equal 3. So let me do for lambda equal 2. Let me see what will happen for lambda equal 2. I let V1. I'm not sure now the matrix is diagonalizable or not. I need to check. So I have what? 4 minus 2, that will be 2. Minus 2, 1, 2. Minus 2, 1, 2. Minus 2, 1. So I have only one equation. That will be 2k1 minus 2k2 plus k3 equals 0. In other words, k3 will be what? K3 will be 2k2 minus 2k1. So I have two free variables. The free variables are k1 and k2. I can't do it another way, but this is the way I'm doing it. So I let k1 to be 1 and k2 0 and k1 0 and k2 equal 1 to be sure they are linearly independent. So k3 will be what? K3 will be minus 2 in this case, and K3 here, it will be 2. So what is V1? I have 1, 0, minus 2. What is V2? That will be 0, 1, 2. Okay, different than what we have there. It's okay. They are correct. So I have two eigenvectors here. Now for lambda, for the other lambda 2 equal 3. Is it 3? Yeah. What I have, let V3 now, K1, K2, K3. Let me see what I will have. That will be 1 minus 2, 1. Then 2 minus 3, 1, 2 minus 2, 0. Times K1, K2, K3. So what are the equations? K1 minus 2, K2 plus K3 equals 0, 2k1 minus 3k2 plus k3 equals 0, 2k1 minus 2k2 equals 0. Okay. Yeah, I need to solve these three equations. From here, I'm getting k1 equal k2. So plug it there. What I have? K1 equal k2. So I have, so make everything in terms of k2. So I have 2k2 minus 3k2. That means k3 minus k2 equals 0. So k3 is equal k2. Plug everything here, I'm getting nothing. K2 minus 2k2 plus k2, that can be 0. So this is nothing I'm getting. So my k2 is free variable. So I let k2 equal 1. I'm getting k1 equal k3 equals 1. So it is my v3, 1, 1, 1. The matrix is 3 by 3. How many eigenvectors I have? I have 1, 2, 3. So A is diagonalizable. And what is D? What is lambda 1? Start with what? With what is it? Lambda 1, 2. So I have 2, but repeated lambda 1. So 0, 2, 0. And this is 0, 0. The second one is 3. And what is P? I need to list the eigenvectors. 1, 0, minus 2, 0, 1, 2. If I put V2 before V1 or V2 or V1 before V2, it will be the same since I have the same eigenvalues. That's the most important. And the last one, it should be 1, 1, 1. So this is my P, this is my T. Yeah, that's mainly the section. Now just we'll do some examples. Yeah, every diagonal matrix is diagonalizable for sure. Okay. If we have n distinct eigenvalues, then for sure the matrix is diagonalizable. Okay, diagonalizable, yeah. Then every n by n matrix with n distinct is diagonalizable. Okay. When they are called diagonalizable, if we have n linear independent eigenvectors, usually we'll find the dimension of all of these eigenspaces. If the total number of dimensions, which is the total number of eigenvectors, is equal to n, then the matrix is diagonalizable. Okay. Yeah. Okay, this is nothing to worry about. Yeah, one thing here, a square matrix is invertible if and only if 0 is not an eigenvalue. Because if lambda is an eigenvalue, if the lambda equals 0 is an eigenvalue of A, then the matrix is not singular, is singular, is not invertible. Okay. I just said how to find diagonalization, find the eigenvalues, find n linear independent eigenvectors. If not, then A is not diagonalizable. P, just list the eigenvectors. D, list the eigenvalues. Okay. Yeah, I think I will stop here. Then I will do different the next group of videos, different example. This is mainly the idea in this section. Okay. So let me stop the recording. Is the recording. Thank you.